Hello student, in last video we discussed the types of redox reaction. Okay, now let us discuss we have the balancing of redox reaction. Okay, here you have to balance the redox reaction. Here we have the two methods. Before going to discuss the two methods, let us discuss first ionic equation. Okay, why? Because means in balancing equation they will give the first we have to write the ionic equation. So first we should come to know what is the ionic equation. Now let us discuss what is the ionic equation. Now if you see here, ionic equation means what? An ionic equation is a chemical equation where the electrolytes in aqueous solution are written as dissociated ions. Means if the electrolytes, if you write as a what? Dissociated ions, that equation is called as a what? Ionic equation. Now if you see example, we have the HCl and reaction with the KOH gives the water plus KCl. In this, what are the electrolytes are there? For HCl and KOH, what you are going to do? You are going to write in present in like as a what? Ions. So this H plus Cl minus, K plus OH minus. This is water and K plus Cl minus. Next, if you see example in this also, what we are going to write? Here we are going to write the equation in the form of ions. Here third example you can see dichromate ion and reaction with the sulfite gives rise to CrO plus 3 and sulfate ion. Okay, the sulfite, this is sulfate. Okay, means ionic equation means what? If you write in the form of ions, that equation is called as a what? Ionic equation. Okay, now here we have some name of the compounds and their ion names. Why? Because means in the balance equation, before going to balance, you should come to know the formula of the each compound or ion. Okay, here we have few compounds and their ion names. Now compound name, if it is given K2Cr2O7 means potassium dichromate. Potassium dichromate, what is the formula? K2Cr2O7. If it's what is ion mean dichromate ion, what is the formula? Cr2O7 minus 2. Next, potassium permanganate, formula is KMnO4. Permanganate ion means what is the formula? MnO4 minus. Next, sodium sulfite. It is important. It is sodium sulfite. Here we have the ite. What is the formula? Na2SO3. Now, sulfite ion means what is the formula? SO3 minus 2. Next, we have sodium sulfate. This is here what? 8. Sodium sulfate is formula what? Na2SO4. Next, sulfate ion means we have SO4 minus 2. So, in the ionic equation, sometimes they will tell sulfite means you have to add SO3 minus 2. Sulfate means you have to add the SO4 minus 2. Next, bromine means Br2. Bromide ion means Br minus. Bromate means you have to add the BrO3 minus. Okay, very careful. Bromine means you have to take the formula Br2. Bromide ion means you have to take the Br minus. Bromate ion means BrO3 minus. Okay, now let us discuss. Here we have the balancing equation. So here balancing of redox reaction. Two methods are used to balance redox chemical equation. Okay, to balance the redox reactions, we have two methods. One method is what? Oxidation number method. Second one is what? Half reaction method or ion electron method. Okay, first let us discuss what is the oxidation number method. In this, here I am going to write the first what are the steps are there, then I will go for the example one by one. First we have to write the skeletal ionic equation. Okay, first they will give some equation you have to write for that skeletal ionic equation. Second one, identify the atoms whose oxidation number is changed. Means simply you have to calculate the oxidation number. Third one, calculate the increase or decrease in the oxidation number per atom. Important, already we discussed. The oxidation number we have to calculate for what? Per atom, and for the entire molecules or ion in which it occur. Okay, you have to calculate the oxidation number change. Okay, then here important, the number of units of oxidation change should be equal to the number of units of reduction change. Okay, the whatever the change is there, it should be equal. So I will discuss with example, don't worry. Next, if you see, if this is not observed, then multiplied by the oxidizing agent with the number of units of oxidation and the reducing agent with the number of units of reduction with the suitable number. What is the suitable number? I will discuss. Next, adjust the coefficient of product accordingly. You have to adjust the product also. Then in the acidic medium, basic medium here is medium is important. If it's acidic medium, okay, if it is acidic medium, you have to balance the hydrogen atoms by adding the H plus ion. If it is for oxygen atoms, you have to balance by adding the H2O at the way deficient side. Okay, you are going to add the at the deficient side. If it is in the basic medium, okay, OH minus means it's why it indicate what? OH minus indicate means basic medium. Sometime on the equation also they will give simply H plus and the arrow mark, okay. And the arrow mark, if it give the H plus means you have to understand, okay, we have to balance the equation acidic medium. If in the arrow mark, if they give the basic medium, simple they will tell as a OH minus. OH minus means you have to understand, okay, that equation we have to balance in the basic medium. Now, in basic medium, to balance the hydrogen atom, you have to add the H2O, okay. To balance oxygen atom, we have to add the OH minus. You should be very careful in acidic medium, basic medium for balancing the hydrogen and oxygen at what deficiency side you have to add. After that, here apply heat and trial method until hydrogen and oxygen atoms are same in number on the both the side of redox reactions. Okay, then you have to go for the heat and trial method. Here important note is what? While balancing hydrogen and oxygen atom, do not disturb the other atoms. We should not disturb the other atom. Okay. Now let us see the example. Okay. Then you can clearly understand what we are doing. Now in the problem number, we have the numerical problem number what? 5.7. First let us, I will read the problem. What is the given there? In problem number 5.17, here write the net ionic equation for the reaction of potassium dichromate. Here already this is our start notation. Okay, in that here you come to know what is the oxidation number of chromium. We have the plus 6. Okay, that is already formula given, K2Cr2O7 with sodium sulfite. What is the formula? Na2SO3 in an acidic solution to give chromium, that is in the oxidation state one, plus 3 ion and the sulfate ion. See, here they didn't give the formula of sulfate ion. So already we know what is the formula of sulfate ion. So potassium dichromate and reaction with the sodium sulfite gives rise to what? Chromium plus 3 and sulfate ion. First you have to go further writing the ionic equation. So we are going to balance this redox reaction in the what? In the oxidation number method. So now let us see the all the steps one by one. Now if you see here, so first I am going to write the in the given this is the given in the problem. So first I am writing the potassium dichromate and reaction with the what? Sodium sulfite. They given the Na2SO3 gives rise to what? Chromium ion, that is plus 3 and the sulfate ion SO4 minus 2. Okay. If you write here SO3 means total balancing will be go wrong. Okay. So they given what? Sulfate ion means SO4 minus 2 you have to write. Now first you have to write the ionic equation. So I am writing this equation in the form of ion. So for this ion is what? Cr2O7 minus 2. Why? Because means we are going to lose the 2 potassium ions. So 2 potassium ions means now the anion is what? Minus 2. This is called as a dichromate ion. Next what we have? Sulfate ion. So this is formula SO3 minus 2. Why? Because means if it is loose 2 sodium ions, you are getting the what? SO3 minus 2 gives rise to already they given the chromium ion, that is plus 3 oxidation state, and sulfate ion is SO4 minus 2. Okay. First is what? You have to calculate the oxidation number. Okay. Here if you calculate the oxidation number, already we discussed the rules. Here chromium oxidation state is what? Plus 6. Okay. This is for what? 1 chromium atom. Already we discussed. Always we will calculate the oxidation number per atom. Okay. For 2 chromium atom 12. But finally what here? For 1 chromium atom oxidation state is how much? Plus 6. Okay. Now in this case if you see the sulfate ion, what is the sulfur oxidation state? If you go for the calculation, we are getting the what? Plus 4. Next here in this case, for monoatomic ion, oxidation number equal to what is the charge? Here we have the charge how much? Plus 3. Next in case of sulfate ion, what is the oxidation number of sulfur? We are going to get what? Plus 6. Now identify them which is oxidation, which is a reduction. Now here if you see chromium plus 6 is converted into plus 3. So here what happened? Decrease in oxidation state. So this reaction is what? Reduction. Now if you see the sulfur oxidation chain, here sulfur we have the plus 4. From plus 4 it is going to convert as a plus 6. So it is increase in oxidation number. So it is called as a what? Oxidation. Okay. Now let us see the steps one by one. So next if you see the steps in this, so you should be very careful by doing the oxidation number method and half electron method. Here what the steps we are going to discuss one by one. So if you see the steps here, so first step is what? First we have to write the ionic equation. Ionic equation already we wrote. Now second step is what? Identify the atoms whose oxidation number is changed. Already here we wrote the oxidation number whose oxidation number is going to change. So here chromium is going to change, in this case sulfur. Here from chromium to chromium there is a change. From sulfur to sulfur here there is a change. So after that what you have to do? Calculate the increase or decrease in the oxidation number per atom, okay, and for the entire molecule or ion in which it is occur. So here already we calculate how much is change we have here. Here if you see plus 6 to plus 3 change how much we have the 3. From plus 4 to plus 6 how much change we have 2. So here next step is what? You have to go for the number of units of oxidation change should be equal to what? Number of units of reduction change. Now if you see here in this case, in this reduction change, how many units we have? Here we have the change is what? Plus 3. Okay, this is nothing but here if you see for plus 3 is what? For what? 1 chromium atom. But total we have how many chromium atoms we have? 2. So 2 chromium atom change how much we have? Number of units of reduction change how much here? This is what? 6 for 2 chromium atoms. Okay. Now if you see here we have the 1 sulfur, no problem. So total change how much we have? 2. But here what we have to make the equal. So number of units of oxidation change should be equal to number of units of reduction change. So do we have here same? No. So you have to multiply with some number that should be equalized. So this 2 number if I multiplied with the 3 that should be equal. So 2 into 3 6 equal to 6. Now the what? Number of units of oxidation change is equal to number of units of reduction change. So we multiplying the what here, the oxidation change we are multiplying with the 3. So same thing, the same number, same coefficient you have to keep in the what? Oxidation change. For this equation you have to multiply it with the 3. So why? Because means here the units are not same. To make the equal we are multiplying with the some number, some coefficient. That coefficient you have to introduce in the equation. Now in the next step what I am doing here, I kept the coefficient as a 3 here. Why? Because means to make the number of units of oxidation change should be equal to number of units of reduction change. Okay, after that what I did, I kept the coefficient 3 here. After that next step what you have to do? Okay, then adjust the coefficients of product. Here reactant I adjust the here I kept the coefficient 3. After that what happened? You have to do the coefficient of product also you have to adjust. Here what are the products we have? Chromium plus 3, SO4 minus 2 is there. So next step I am going to adjust the coefficients of the product. So how means? Here we have the 2 chromium atoms, but in this we have the only 1 means if I keep the coefficient 2, now chromium atoms are balanced. Next if you see here, sulfur, here we have 3 sulfur atoms in the case of reactant, but in the product we have only in this part 1 is there. So I kept the coefficient 3. Now what happened? Other than, important, other than oxygen atoms, remaining atoms are balanced. Okay. Now you have to balance the hydrogen and oxygen atom. Now the steps are important. So for balancing the hydrogen atom and oxygen, first you have to see the in which medium. Okay, the problem already given, you have to balance the equation what? In acidic medium. So important, in acidic medium, to balance the oxygen atom, add H2O. For balancing the what? Oxygen atom, you have to add the H2O. Now where I have to add mean? First I will go for the, see how many oxygen atoms are there from each reactant and product side. In this now if you see here 7 oxygen atoms are there, here 9 oxygen. 9 how? Here 3 into 3 how much? Total number of oxygen atoms 9. Total we have the 16 oxygen atoms at the reactant side. Now if you see here 3 into 4 means 12 oxygen atoms are there. Here 16 and 12. Okay. So where we have the less number of oxygen atom? At the reactant side. So now you have to add the 4 H2O molecules. Why 4? Why? Because means from each water how many are going to get? Each water you are getting the only 1 oxygen atoms. So how much deficiency is there? To make the 16 here means I have to add the 4. If I add the 4 H2O means now 12 plus 4 oxygen it will be equal. So now 16 oxygen, 16 oxygen. So now what I did here, I added the 4 H2O to balance the oxygen atom in acidic medium at the reactant side. Now what happened? There is an imbalancing in the what? Hydrogen. So for balancing hydrogen atom in acidic medium what? We have to add the H plus. Now where I have to add mean? First I have to go for the See where the deficiency of H plus is there. See here already we added the 4H2O. Here we don't have any hydrogen atom. So I have to add at the reactant side. Now if you see here, so if you see here what happened, how many hydrogens we need? 8. How means here 4 into 2, how many hydrogen atoms are? How? 8 is there. So here we have to add the 8H plus ions. Now balance the hydrogen atom by adding the what? 8H plus ions. So we added the 8H plus ions at the reactant side. Now after balancing along with the atoms, charges also should balance. Very very important. After balancing not only the atoms, if you see now all atoms are balanced, along with that you have to see the charges also. First let us see the atoms are balanced or not. Here we have the 2 chromium atom. Here also 2 chromium atom. 3 sulfur atoms, 3 sulfur atoms. Now let us see the oxygen. Here we have the 7. Here after that how many are there? 7 then plus 9. Okay. Now here total how much we have? 12 plus 4 into 3, 12 plus 4. So how much here? You are getting the total 16. So here 16, here 16. After that see the hydrogen atoms. Here we have the 8 hydrogen atoms are there. Here we also have 8 hydrogen atoms. Why? Because means 4 into 2, 8. Okay. Now atoms are balanced. But what about the charges? If you see the charges, here total charge how much we have? Minus 2. Okay. Minus 2. Then 3 into minus 2. Here you have to see one sulfate ion charge is minus 2. But total how many sulfate ions we have? 3. So total how much here? 3 into minus 2 means minus 6. So minus 6 minus 2 total how much we are going to get? Minus 8. Okay. Next after that here we have the, this is minus 8. Now we have the plus charge on the hydrogen. Total how many hydrogens are there? We have the 8. So 8 plus. So minus 8 from here, from these two minus 8. This is plus side. Total net charge how much? 0. On the reactant side, total net charge how much? We got the 0. Now come to here product side. Here product side, here if you see one chromium atom charge is plus 3. But total how many chromium atoms we have? 2. So 2 into plus 3 plus 6. Okay. Next if you see here, one sulfate ion is minus 2 charge. But how many are there? 3. 3 into minus 2. So minus 6. So plus 6 here, minus 6. Total how much? 0. So here what are the values you are getting? You should be get the both the sides same. For example, I got here minus 2 means this side also we have to get the minus 2. Means along with the atoms you have to balance the charges. Then only we can say the reaction is what? Redox reaction is balanced. Okay. This is the steps how we have to do the equation in the acidic medium. Now same equation I am going to balance in the one basic medium. Okay. So same equation, actually in the textbook we have the acidic medium. So for the sake of convenience, I balance the equation in the basic medium also. Now if you see here, the same equation, if I go for the balance the equation the basic medium, first what happened here, we up to date same step. Okay, whatever the medium is there, acidic or basic medium, this up to this one is same. But after now, here what happened, we don't have the sufficient oxygen here. Okay, so first what happened, first you have to balance the oxygen. So first balancing oxygen atom, first add OH minus ions at the deficiency side. So in the one basic medium, you have to add the for deficiency of oxygen, you have to add the OH minus ions. Whereas in case of acidic medium, what you are doing, you are going to add the H2O. Okay, here you are going to add the hydroxide ion. But in case of acidic medium, you are adding the what? H2O. Now, so here just count the number of oxygen atoms. Here, to 7 plus 3 into 3, 9. Total how many oxygen atoms we have? 16 oxygen atoms. Now in this case, here for 4 into 3, 12. Only we have the 12 oxygen atoms. So to balance that one, what we are doing, we are going to add the 4 OH minus ions. Why? Because means for 1 OH minus ions, you are getting the what? One oxygen atom. So how many deficiencies we have? To make the 16 this number means we have the 4. So I am adding the 4 OH minus ions at the product side. Okay. So now if you see here, so in the next step what I am doing, I am going to add the 4 OH minus ions at the product side. Next what happened, there is imbalance of hydrogen ions. So balance the hydrogen atom by adding the H2O here. Okay. So important basic medium for balancing the hydrogen, what you are going to do, you are going to add the H2O. Whereas in case of acidic medium, what we done, we added the H plus ion. Okay. Now if you see the count the number of hydrogen atoms, here we have the 4 OH minus ions are there, but means 4 hydrogen atoms are there. But here what happened, we don't have any hydrogen atoms. So to add this one, I am going to add the 2 H2O. Why? Because means for one water molecule, you are getting the how many how many hydrogen means 2, okay. Here we need the 4, means 2 is sufficient, okay. Why? Because means 2 into 2, 4, okay. Now Cr2O7 plus, already equation is there, just in the next step you added the what, 2H2O gives rise to, this is equation is balanced. But if you see here, in the above equation atoms are balanced, but not the charges. In this, if you see, all the atoms are balanced but not the charge. Here see, here chromium 2, Cr2 is there, okay. Here we also have 2 chromium atoms, sulfur 3, 3 sulfur atom, oxygen also balanced. But what is the problem here? There is no balancing in the charge. Let us see here. Here we have the minus 2, 3 into minus 2 means minus 6, minus 6 plus minus 2 means minus 8 is there. But here in this case, if you see, we have the plus 6, minus 6, total 0. Here we have the balance is minus 8, but here what happens? 0. There is a no balance in the, means the value should be same. If it's minus 8 means it should also be minus 8. So what happened? Here we atoms are balanced, but there is a no what, balancing of charges. So apply hit and trial method until charges balances. So here you have to go for the hit and trial method. Hit and trial method means simply you have to change the coefficient of H2O and OH minus only. You should not touch the other coefficients. So change only number of hydrogen and oxygen atoms only. You have to, while hit and trial means just you have to apply. You have to go for the, okay, this number is suitable or not. Next, if it's 2 not suitable, go for the 3. Then 4, 5, 6, like that you have to go. I mean you are going on changing. That is called as what? Hit and trial method. So once after that, so while doing the hit and trial method, you have to change the only coefficient of H2O and OH minus only. You should not touch any other coefficient. Now if once after going the hit and trial method, final equation is what? Here you are going to get the final equation in basic medium, okay. So this is equation, means this here if it is 4 and here if it is 8, then you are going to get the what? Equation along with the balance equation along with the charges. Now let us see the charges are balanced or not. Here 2 in minus 2 into 1 means minus 2. Here 3 into minus 2 means minus 6. Total how much we have? Here minus 6, okay. So balance equation is what? Minus 6 here. Okay, let us see here. Sorry, okay. So if you see here, this is the 3 into minus 2, minus 6, here we have minus 2. So minus 8, here we have total charge. Now here if you see here, this is plus 6, here we have the minus 6. So plus 6 minus 6 going to get cancelled, 0. Now here we have 8 OH minus ions. So 1 OH minus ion charge is what? Minus 1. Here we have total coefficient how many? 8, means 8 into minus 1 minus 8. If you now go for simplification, how much we are getting? Minus 8. So minus 8 at the reactant side, both sides we have the same value. Now the balanced chemical equation in basic medium. This is called as a what? Balanced chemical equation in the basic medium. So you have to change the only number of what? H2O and OH minus. You should not touch the any coefficient of any other reactant and product, okay. This is about the balancing equation in the what? Oxidation number method.